We're in Ossining, New York. We're doing four-wall system in this particular basement. And when you walk in, you'll see you got a cement floor. It goes right up to the wall. Your walls are coming down. And you think it's just a standard, normal waterproofing job. And then as you get into it, all sorts of things can occur that just aren't visible when you first walk into the basement. So when we're doing our initial inspection, in a basement, we're looking at, you have this floor's been painted a couple different times, which means they've had water is like the anti-paint. It gets down, it gets underneath, it bubbles up, and then it peels it off. A couple different things. There's the way paint gets peeled off a wall. It's a little different scenario, but all because of water. Now, I digress a little bit here. This wall, the foundation wall that is, not the drywall, is sitting on a footing which is usually 16 inches wide. That's a standard footing, and a wall's 8 inches, so that's put in the center of 16. If you put 8 in the center of 16, you're gonna get a 4-inch ledge on one side, the outside, and then a 4-inch ledge on the inside. And the floor is set up, and this is what the engineers have done in order to give strength and integrity to your foundation. That 4 inches on the inside, the floor is poured all the way over, and it sits on top of that concrete ledge, the 4 inches on the inside of your walls, and that holds up your floor. It's very important. That's why we leave engineering tabs and engineering spacers to keep the main body of the floor all one piece over on top of the footing. So it's being held up, and we're not creating a floating slab. This particular foundation threw an entire curveball. It went in, and I was measuring, and it's about 3 inches thick, right around 3 inches thick. Traditional floors are 4 inches, but the footing on this particular floor was extra high. So as the 3 inches came across the entire main body of the floor, as it got to the footing, it narrowed down and got very, very thin. We're wondering why was that? Well, as we started to take the floor out, what we found were an enormous amount of boulders that were in here, and as we got to the back wall, it was solid ledge, solid rock across the entire trench, and that's why they thinned the floor out, because rather than spend an enormous amount of time chipping away at solid rock, they just poured the floor, thinned it out, and got it over on top of the footing. What we're gonna do is get an enormous amount of drainage in here, regardless of whether there's ledge or not. This originally was going to be a 2-day job. We're in day 5 right now, and we'll be finishing up today. And we know sometimes the bear gets you, sometimes you get the bear, so to speak. And this particular time, the bear got us. We stuck to our guns and did it exactly the way that we needed our system to be installed. A super high volume system that handles all of the hydrostatic water coming up underneath the floor. This place, we did the trench, we put it all in, and then they had to get their pipe in and their stone in. And the most important aspect of any subfloor, meaning in other words below your cement, water management system, is the pitch and placement of the pipe. The pipe has to be pitched, but it has to be done so in a way that it always stays within the depth of the footing. You don't want a pipe ever below your footing, because then it starts to pull soil out from underneath your footing and it'll undermine it. If it's next to the footing, it's next to a concrete wall, the pipe drainage here you can pitch, but you're actually locked into the depth of the footing. Some footings are 12 inches, some are 14, some are even 16 inches. So once you establish that, you know how you have to work your pitch with the pipe to keep it next to that concrete footing, or a concrete wall, if you will, so that water has to rise up to the pipe. Now that's the proper way to manage water. If it rises up to the pipe, it's crystal clear, it looks just like spring water, actually is spring water, and will never bring any of the silt or soil from underneath the footing or from the trench, because the water is perking up and rising up to the pipe, to the stone, and then being carried around to our heavy-duty commercial pump, and then being pumped outside to a stone field. And when you see the stone field, it's a pretty significant stone field that they did as far as for a discharge line would go, above and beyond what you'll ever find with anybody else that does basement waterproofing. Very, very effective. If you did enjoy the video, hit the like and subscribe. Until next time, enjoy your dry basement.